Hi, this is just a little video to help you as you are preparing for the wave test. So we're going to go through the basic things that you need to know in order to do well on the wave test. So to start, we have waves that are called transverse waves. Transverse waves are light waves, or light waves are an example of transverse waves. And transverse waves look like this. Okay, so they come up and down and up. We have crests, we have troughs. You measure the amplitude of these waves from the middle line to the top of the crest, or you could do the middle line to the bottom of the trough. And you measure the wavelength from trough to trough or from crest to crest. Okay, so amplitude is the height, and wavelength is the distance between our waves. So the distance between our troughs or crests and crests. So that being said, as we increase energy, what happens to the amplitude? Does it increase, decrease, or stay the same? Well, the amplitude increases. So that means that a wave with more energy is going to be a taller wave. It's going to have more energy. Okay, if we increase the energy, what's going to happen to the wavelength? The wavelength is going to decrease. It's going to get shorter as our energy increases. So that means, looking back at this picture, as we increase energy, amplitude is going to increase. So this wave is going to get taller. As we also increase energy, though, our wavelength is going to get shorter. So our crest to crest are going to come closer together. Also, we need to know, that as we change amplitude, changing amplitude in a wave, a light wave, changing amplitude will change what about the wave? Well, what about the light? Changing amplitude will change the brightness of the light. So the taller the amplitude is, the brighter the light. The shorter the amplitude is, the dimmer the light. So amplitude changes brightness. Okay, then if you changing wavelength will change the color of light, or the type, color of light or type of light wave. So what do I mean by that? Well, let's look at this picture. So remember when we talked about the electromagnetic spectrum? Okay, we got radio waves on it, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. We got and the only difference between all these different types of light waves is their wavelength. So as we have longer wavelengths and we get to shorter wavelengths, all that's changing is the wavelength. So as we change wavelength, we're going to change the type of wave that we have. We'll also change the color. So looking at this picture, red has a longer wavelength, and as we go down the rainbow, we get shorter and shorter wavelengths. So we get down to blue and violet, and they're going to have the shortest wavelengths. So remember that red is long, and then Roy G. Biv are red, orange, yellow, green, blue, violet. Violet and blue are short wavelengths. Okay, very good. Next, we have longitudinal waves. Longitudinal waves. And longitudinal waves are sound waves, or an example of longitudinal waves is sound waves. So same as before, if we increase, let's look at a picture of them really quick. So here's a picture of a longitudinal wave. So you'll notice we have these places where the lines are close together, then they become more spread out, then close together, then more spread out, then close together. So these sections where the lines are close together are called compressions. And those compressions are going to help us to figure out where our wavelength is and where our amplitude is. Okay, so we can measure wavelength from this cluster to this cluster. Okay, that's our wavelength. And you could also measure from this cluster of lines, this cluster of lines. Okay, that's also could be the wavelength. Then you're going to measure amplitude by looking how close the lines are inside our compression. So you look at these compressed spots and you look and say, okay, the closer the lines are, the greater the amplitude. Okay, so I'm going to come back here. The closer the lines are inside the compression, the greater the amplitude. Wavelength is measured from compression to compression. All right. What else do we need to know? Well, it's going to have these same relationships as we set up here. As energy increases, amplitude increases, meaning our lines inside the compressions are going to get closer together. Also, as energy increases, wavelength decreases, meaning that our compressions are going to get closer together as energy increases. What else? Oh, so in a sound wave, when we change the amplitude, changing the amplitude is going to change the loudness of the sound. So when we're looking at these sound waves, okay, so here is our example, D through F are examples of sound waves. If we change the amplitude, we're going to change the sound. So between D and E, so D and E, D has closer together lines in the compressions. So that means D is going to be a louder sound than E because D has greater amplitude. Okay, so when we change the amplitude or how close the lines are together in the compressions, it will change the loudness of the sound. Okay, next, changing the wavelength will change the pitch of the sound. So whether you have a high pitch, so we can have a high pitch. So imagine for a high pitch, a really young girl screaming at the top of her lungs. She's going to have a really high pitch. So a high pitch is going to be represented, by a short wavelength. A low pitch is going to be represented by a long wavelength. So for a low pitch, imagine like a really big muscly guy and he yells, his low pitch yell is going to have a low wavelength. Or you can think about the highest note you could sing on is a high pitch, and that's kind of a short wavelength, and the lowest note you can sing is going to be a low pitch and a long wavelength. Good, so if we look back at these pictures, okay, when we look at between D and F, which one has the higher pitch? Well, D has the higher pitch because the wavelength is shorter, whereas when the wavelength gets longer, it's a lower pitch. So D would be a higher pitch than F. Last couple things you need to know. Mechanical waves versus light waves. What's the difference? Okay, well, these are just two categories that other types of waves can fit in. A mechanical wave, the main difference is this: mechanical waves need a medium, meaning they need a substance to travel through, or else there won't be a wave. Whereas light waves do not need a medium. Okay, so thinking about outer space, mechanical waves, they cannot travel through outer space because outer space is a vacuum. There's not enough substance, there's not like a gas out there that the mechanical waves can travel through. Whereas light waves, they do not need a medium, so light waves can travel through space because they don't need a substance to travel through. So let's look at this. So mechanical waves need a medium. So what is an example of mechanical waves? Longitudinal waves are mechanical waves, or they're also called sound, right? Longitudinal sound waves are mechanical waves. They need a medium. Whereas transverse waves or light waves do not. They do not need a medium. Okay, so all you're going to remember is mechanical, which is M. Mechanical waves need a medium, also M. Mechanical medium, mechanical medium. Great. We practice looking at waves for high and low pitch and change the amplitude. And sound waves, let's just look at a couple light waves and then we'll finish up. So if we look at these light waves that we have here, okay, looking between A and B, which one is going to be a brighter light? A is going to be the brighter light because it has a taller amplitude. Okay, then looking between A and C, A and C, which one is going to be more likely to be a red color? Which one's more likely to be a blue color of light? Well, C is a longer wavelength, and just like we looked at here, red has a longer wavelength than blue and purple. So coming back here, C is more likely to be a red light, whereas A is more likely to be a blue light. So that's all you need to know. Oh, the last thing that you need to know is transmitting, reflecting, and absorbing waves. So if you look at this bottom picture here, okay, this first picture of the mirror, the wave is coming in, hitting the mirror, and coming back off. That's called reflection. So, or a reflect. So it's kind of like an echo, okay, when the sound or light waves hit something and comes back off. The second picture here is a picture of absorption. So a light wave coming to hit the house and stopping. It's being absorbed by the object. Or lastly, we have an example of a light wave being transmitted or transmission through this window. So light or sound going through something is called transmission. That is all you need to know. If you have questions, feel free to email me. Thanks, guys. You're going to do great tomorrow.